Let me record this. Okay, so we talked about adding fractions with algebraic expressions before, right? And the trick is, just like adding any fractions, you need to find what first?
Common denominator.
You have to find common denominators.
Exactly. You have to find a common denominator first. Okay? Is that what you were going to say, Mark?
Yeah.
Yeah, exactly. So even if the common denominator is like xy squared, you might have to multiply a fraction by x over x or y over y or y squared over y squared. Because remember, when you multiply it by any variable over itself, it equals 1. And so multiplying any fraction by 1 doesn't change the fraction. So these are all things to remember as we're doing this. So now the only thing that this lesson adds to what we did last time with adding algebraic expressions is negative exponents. What does a negative exponent tell us to do again?
Multiply by the reciprocal.
Nope, just take the reciprocal.
Oh, yeah, take the reciprocal.
Dividing is multiplied by the reciprocal.
Yeah.
Right? So to get rid of a negative exponent, you just change, you move the term on the other side of the fraction line. And then it changes positive. Everybody remember that from negative exponents, or do we need to go into more detail with those? Rosie, are you good, or do you want more detail with negative exponents?
I'm good.
Okay, Mark?
I'm good.
Okay, so if we're adding fractions with negative exponents, you get rid of the negative exponents first, and then you do it just like we did last time. Nope, that's it. So if you have a negative exponent, it needs to be in a denominator, unless it's already in the denominator, and then it needs to be in the numerator. And then you find your common denominators, then you add. It's not complicated at all. So here's a couple of examples. Let's go through them. So we have z to the negative 2 plus y to the negative 1 plus x. Okay, pretty straightforward. Negative exponents. First thing we need to do is make them not negative anymore. So move them to the other side of the fraction line. So z to the negative 2 is the same as 1 over z squared. Y to the negative 1 is the same as 1 over y. You guys got that? Does it make sense?
Yep.
Mark, you got that? Good. Rosie?
Yeah.
That first step is the only thing that we're learning this lesson. The rest of this is the exact same as the problem we did last week. Okay? Exactly.
Yeah.
Yes. Yeah, we're doing a lot of incremental lessons, just so you guys know. So don't be so frustrated about math, because all we did was just, oh, hey, a negative exponent. Let's just treat that as a denominator like it should be. And then now we know how to solve this. It's funny, when you get into higher math, you do proofs and, you know, what have you. It's besides the point, but you're proving that you can do something. And one of the strategies for doing proofs is you reduce a problem to one that you've already proven. And so in this case, we're reducing the problem to one that we know how to solve. Pretty straightforward. So let's continue on with this one. The common denominator between z squared, y, and 1 is yz squared. Everybody understand that common denominator there? Mark?
Yep.
Rosie?
Yep.
Okay, good. Bella's nodding also. So in yz squared is the denominator. 1 over z squared, it's missing a y. So we need to multiply it by y over y. 1 over y is missing a z squared. So we need to multiply it by z squared over z squared. And x is missing the entire denominator. So we need to multiply by the entire common denominator of yz squared over yz squared. Sound good?
Mm-hmm.
Okay. And then we just multiply. So 1 times y is y. Z squared times y is yz squared. 1 times z squared is z squared. y times z squared is yz squared. And x times yz squared is xyz squared, and yz squared times 1 is just yz squared. How do you know you did it right? All of the fractions will have a common denominator after you're done. If they don't have a common denominator, you either didn't figure out the common denominator right, or you didn't multiply everything by what they need in order to get the common denominator. Go back and redo it until they all have a common denominator. Okay, so now the common denominator is yz squared, and so we just add x plus z squared plus xyz squared, and the whole thing is over yz squared. Good?
Yep.
Okay, great. Bella's nodding also. Let's do the second one now. Just as simple, not that hard. Remember, the only thing we're learning here is just get rid of the negative, and then we know how to solve the problem. So 3x to the negative 1 plus 2y. X to the negative 1 is just 3 over x, right? And 2y is just 2y. Does that make sense? You got that first step there, Rosie? Mark,
Yes.
you got that first step? Does that make sense?
Yeah.
Okay, good. So now let's find a common denominator. The common denominator between x and 1 is x. Okay, 3 over x already has the common denominator. We don't need to multiply it by anything, so we're not going to. 2y needs an x in the denominator, so let's multiply it by x over x. 2y times x equals 2xy. So we have 3 over x plus 2xy over x, which gives us 2xy plus 3 over x. Does that make sense? You
Yep.
good, Mark?
Yeah.
You good, Rosie? Rosie, can't hear you. Yeah. Okay. Any which way. So here, that's pretty much it.